Hello, welcome to Lesson 2.2, Conditional Statements. Today's objective will be to identify, write, and analyze the truth value of conditional statements and to write the inverse, converse, and contrapositive of a conditional statement. We will learn what all these terms mean throughout the lesson. This lesson will move fairly quickly, so please don't hesitate to pause or replay parts of the video in order to stay caught up. Let's begin by doing the following warm-up. Determine if each statement is true or false. Please pause the video so you can have time to fill out your answer to each question. Okay, hopefully you had a chance to fill those out. Let's take a look at the truth value of each statement. The measure of an obtuse angle is less than 90 degrees. We know that obtuse means more than 90 degrees, but less than 180, so this is a false statement. Second, all perfect square numbers are positive. You find the perfect square of a number by taking your integers and squaring them. The first perfect square is the number 1. 1 times 1 is 1, but it has a negative counterpart. Negative 1 times negative 1 is actually positive 1. And the same is true for all integers squared. When you square an integer, you get a positive number. So all perfect square numbers are positive. This is true. Every prime number is odd. Well, prime numbers are numbers that only have factors of 1 in themselves. So if I consider a number like 3, that is only 1 times 3 is the only way to get 3. But if I consider a number like 2, 1 times 2 is 2, but 2 is an even number. In fact, 2 is the only prime even number. Any even number greater than 2 is not prime. It is considered composite. So this is false. Number 4, any 3 points are coplanar. We know by the definition of a plane, it takes 3 points to determine a plane, so any 3 points would always be coplanar. Now let's take a look at our first of the new material. Let's talk about what a conditional statement is. That's the first part of today's lesson. A conditional statement is any statement that can be written in the form if P, then Q. That means an example would be, if it's raining outside, then I need an umbrella. A conditional statement is made up of 2 parts, the hypothesis and conclusion. The hypothesis is the part of the statement that follows the word if. It's represented with the P in this example. The conclusion is the part following the word then. It's represented with the Q. The hypothesis is the condition that must be met for the conclusion to be true. So we could represent it with symbols. If P, then Q is how this would be read. We can also represent this with a Venn diagram. If something falls in the P category, then it also falls in the Q category according to this Venn diagram. In example 1, we are to identify the hypothesis and conclusion of each conditional statement. You are to underline the hypothesis once and the conclusion twice. All right, hopefully you've completed this. Let's take a look at what you should have. If today is Thanksgiving Day, then today is Thursday. The condition that must be met in order for it to be a Thursday in this statement is that it is Thanksgiving Day. That's the hypothesis, following the word if. The conclusion is the conclusion following the word then. Today is Thursday. In part B, a number is a rational number if it is an integer. Notice this does not start with the word if, but it rearranges the order of the sentence. The hypothesis still follows the word if, even if it's in a different place of the sentence. So the hypothesis is that it is an integer. The conclusion is that a number is a rational number. You'll notice that if P then Q could be written differently, as you saw in the last example. Here are the other ways we could write a conditional statement. Instead of saying if P then Q, if it's raining, then I need an umbrella, we could say if P, Q. If it's raining, I need an umbrella, using the comma. We could also completely rearrange the sentence and say, I need an umbrella if it's raining. So in example 2, we need to write some conditionals based on given statements. An obtuse triangle has exactly one obtuse angle. We could write that. If a triangle is obtuse, then it has exactly one obtuse angle. We could also rearrange the order of this one and say if a triangle has exactly one obtuse angle, then it is an obtuse triangle. Part B, we have a Venn diagram. Blue jays are a subcategory of birds, so we could write it this way. If an animal is a blue jay, then it is a bird. Or you could just say, if it is a blue jay, then it is a bird. Part C, two angles that are complementary are acute. We could write that as a conditional statement. If two angles are complementary, then they are acute. So we need to be able to evaluate a conditional statement based on its truth value, whether it is true or false. And this is going to take a little bit of a stretch for some of us to comprehend, but a conditional statement is only false, meaning the only way to verify that a statement is false is when the hypothesis is true or satisfied, but the conclusion is false, meaning if you have something that can be verified to fit this hypothesis, but it disproves the conclusion, then your overall conditional statement is accepted as false. To show that a conditional statement is false, then, we need to provide a counterexample that satisfies the hypothesis but not the conclusion. So let's practice this. I want you to determine if each conditional statement is true. If it is false, give a counterexample. If you're not able to give a counterexample, remember you must assume it's true. Take a few moments and decide whether these are true or false. All right, let's figure this out. If this month is August, then the next month is September. We know that is a true statement based on our understanding of how the calendar works. Part B, if two angles are acute, then they are congruent. Well, I can break this down. I can think of two acute angles that are not congruent. It's something that satisfies the hypothesis but not the conclusion. So I'm going to say that this is false, and I'm going to write a counterexample. We could think of two acute angle measures that are not the same measure. Any acute angle measures that are not the same will work. We could pick 10 degrees and 20 degrees. Those are acute angle measures, but they are not congruent angle measures. So this is false, and that's our counterexample. Part C, if an even number greater than 2 is prime, then 5 plus 4 equals 8. We discussed this just a moment ago in our warm-up, that the only even prime number is 2. So if an even number greater than 2 is prime is a condition that cannot be met. This is a mathematical impossibility. Our hypothesis, then, is false. There's no way to disprove this statement based on our given condition that cannot be met. So we need to assume that this statement is true. While I know this is a confusing concept, this is something we will discuss further during class time. Part D, a little bit easier to understand. If a number is odd, so think of the odd numbers, then it is divisible by 3. Well, we can have a condition that is met here in our hypothesis. We can have an odd number. It's very simple. But we can also think of an odd number that is not divisible by 3. So we know this is false. Okay, and a counterexample would be something as simple as another odd number that is not divisible by 3, such as the number 5. Five is odd, but not divisible by 3. So let's continue with our notes. Remember, if the hypothesis is false, the conditional statement has to be assumed to be true, regardless of the truth value of the conclusion. Let's take a look at the negation of a statement. This is something that you would make the negative of the statement, meaning if it says something is a certain way, the negation of that would say that it is not a certain way, and we would represent that with this symbol, a tilde before that statement. It means not that statement. So we're going to use that in our following vocabulary. If you'll remember, we've talked about conditional statements that are written in the form if P then Q, and we could write it in symbols, P with an arrow pointing to the Q. We're going to talk about the converse, inverse, and contrapositive of each statement. The converse of a statement is the statement formed by exchanging the hypothesis and conclusion. So we wouldn't read it if P then Q, we would read it if Q then P. exchanging, changing the order of your statement, but leaving the if and then in the same spot. The inverse of a statement is formed by negating the hypothesis and conclusion. We go back to our original order, P followed by Q, but then we negate each of those. If not P, then not Q. And lastly, the contrapositive is found by both negating and exchanging the hypothesis and conclusion. If not Q, then not P. So let's take a look at example 4, where we are to write the converse, inverse, and contrapositive of the conditional statement. This will be a time when you may want to pause the video to get all of these written down. So we're going to use this scientific fact. We're going to base our statements on fact that adult insects have 6 legs and no other animal has 6 legs. So here's our conditional statement. If an animal is an adult insect, then it has 6 legs. The converse of this statement is found by changing the hypothesis, an animal is an adult insect, with the conclusion, it has 6 legs. So the conclusion becomes your hypothesis becomes your conclusion. If it has 6 legs, then an animal is an adult insect. The inverse is found by going back to your original, and we will not change the order. We will leave the order the same, but we will add the word not. We will negate it. So we would say if an animal is not an adult insect, then it doesn't have, or we could use the phrase has not 6 legs. That is correct English, but it sounds a little bit different. The contrapositive is found by both negating and changing the order. So I'm going to use these phrases where we've negated each of these, and I'm going to change the order as well. So I would say if it doesn't have 6 legs, or if it has not 6 legs, then an animal is not an adult insect. That's how you find the contrapositive. So when we talk about truth values of statements, we have certain statements that will be logically equivalent. Logically meaning pertaining to their truth value, equivalent meaning equal. So if we have a conditional statement such as this, if the measure of angle A equals 95 degrees, then angle A is obtuse. We can assume that is a true statement. We know that that fits the definition of obtuse angles, so it's true. The converse of that would say this: if angle A is obtuse, then the measure of angle A is 95 degrees. That is not necessarily true, so we claim it is false. We can think of a counterexample. The inverse goes back to the original and just changes to not 95 degrees and not obtuse. If the measure of angle A is not 95 degrees, then angle A is not obtuse. I can think of a measurement that is not 95 that is still obtuse, so this is also false. And then our contrapositive changes the order and negates the statement. So our contrapositive would be stated this way: if angle A is not obtuse, then the measure of angle A is not 95 degrees. This goes back to our original truth value. This is a true statement. You cannot have an obtuse angle, or you cannot have angle A be 95 degrees and it also be obtuse. So this is also true. Thank you for watching your video over the notes today. It's been a little bit longer. Hopefully you had a chance to pause and get everything filled in. If you have any further questions, please bring them to class. We will discuss this in further detail and start the assignment when you return to class.